Hello everyone, this is BV Aramat. Today we are going to discuss the next one of the important part in the current electricity. That is, there are three derivations here we want to derive today. One is current in the simple circuit. Now we want to discuss the concept of current in a simple circuit, and when the cells are connected in parallel and when the cells are connected in series, then what about the derivation. So now we want to discuss these three concepts, which first one is the current in a simple circuit. See students, here there is a simple circuit diagram is given. Here one is a positive electrode, another one is, which is taken as a P, another one is a negative electrode which is a N, which is dipped in the electrolytic solution. So here A and B, which is represented a potential point, and which is connected to C, then C is connected to D through the help of resistance R, then again which is connected to N. This is one of the closed circuit. Now see, consider a simple circuit in which the resistance R is connected to a cell of the EMF. Cell of its EMF is E. Then its internal resistance you can consider as a small r. So its EMF is taken as E and its internal resistance is considered as a R. Internal resistance is considered as R. Then which is as shown in the figure. If the resistance R is infinite value, sorry, if the R is a finite, first we will discuss about the concept of finite value. If the resistance R is finite value, then the steady current I is flowing through the circuit. If V is the potential difference across the positive terminal P and the negative terminal N of a cell. See the potential difference between positive and negative terminal, which is taken as a V. Then so the potential difference can be defined or defined like this. You can write the formula like this. See, the potential difference V is equal to potential difference between P to A. See, the potential difference between P and A plus potential difference between AB plus potential difference between B and N. So this is, we can call it as a total potential difference. So the total potential difference V is equal to potential difference between P and A plus potential difference between AB plus potential difference between B and N. See, this is like this: P to A to B, and B to N. So this is the potential difference, total potential difference. That can be written as in the formula: the potential difference across PA. This is a positive potential here, that's why it is taken as plus V. Then potential difference of between AB. See here, this is a electrolytic solution here, in which potential difference can also define like using Ohm's law. V is equal to IR. Here I is a current flowing through the electrolytic solution and R is the internal resistance. See, this is the internal resistance. Then the potential difference between A and B is, we can take it as IR, where R is the small r here, not capital R. Capital R considered as a external resistance, then small r is considered as a internal resistance of a cell. Hence the potential difference across AB is equal to IR. So that is in terms of negative. Then another one is potential difference across B to N is considered as a minus V. Then so it becomes now the potential difference. One more definition is there, that is a definition of EMF. According to definition of EMF, the potential difference between positive and negative electrode of a cell, that is called as EMF. Hence the potential difference between positive electrode and negative electrode, so plus V plus of minus V, so that is taken as EMF. Instead of plus V and minus V, plus of minus V, this is considered as a EMF of a cell, and minus IR capacities. Since you know that E is equal to plus V plus of minus V is the EMF of the cell. The negative sign of for IR, that is because of the current through the electrolytic solution that flows from B to A. Since V is also potential difference across R, then we have V is equal to IR. See here, here in this case the current which is that is in the equation, that is minus IR is considered. That is nothing but the negative sign that indicates current flowing in the electrolytic solution, that is flows from B to A. The current is flowing in this direction, but we are considering B to A to B, B to N, that is opposite to the that's consideration. That's why, so here the in the equation this is considered as a minus sign. Then the potential difference across R, so the potential difference across R is considered as a V, and here the potential difference V is equal to I into R, so that is represented here. See, V is equal to E minus IR is equation number 1, and then in the external circuit, then V is equal to IR is the equation number 2. From the equation number 1 and 2, on combination of these equation number 1 and 2 we have, so IR is equal to, see, because V here also V, here also V, hence IR is equal to E minus I into small r. Then here we can, now we want the expression for current through the simple circuit. That's why here in this case, so IR terms send it to LHS side, then minus IR becomes plus IR, then I keep it outside, remaining term R is already there, R plus this R is transferred to LHS side, then the equation is equal to I into R plus R, that is equal to E. But we want current, hence R plus R send it to RHS side, hence we have the equation is equal to I is equal to E divided by capital R plus small r. This is an expression for current through the simple circuit. See here one more, this is a very important derivation for 3 marks, that is a current through a simple circuit, I is equal to E divided by R plus R. See the above equation, so the above equation that that shows the current in a resistance R connected to a cell of EMF E and its internal resistance is R. Then the maximum current can be drawn from a cell. See, this is the case here in which the expression shows the current through a circuit of resistance R connected to a cell and the cell having internal resistance R. Then the maximum current can be drawn from the cell is for the which value, means for if the R value is 0. If the resistance value is 0, then the circuit that draws maximum current. In such a condition, see, if R value is, see in here in this case, if R value is 0, then maximum current is equal to E divided by small r, that is equal to, so maximum is current is equal to E divided by small r, where small r that represents the internal resistance. Current allows, that allowed is much lower than this to prevent permanent damage to the cell. From equation number 2 and 3, so that we get V is equal to, we know that V is equal to IR from the Ohm's law, V is equal to IR, then in place of I you need to substitute this equation, sorry, in place of I, the value, we know that one more value, there is a current through a simple circuit, that is I is equal to E divided by R plus R. Then in this equation V is equal to I value is E by R plus R, then capital R keep as it is. This is equation number 4. This is the expression for potential difference. Equation 4 that gives the potential difference across the terminals of a cell. When the cells is in the closed circuit or when the current flowing through the circuit. And this is called as a terminal potential difference. See, this equation is called as terminal potential difference. Generally, the terminal potential difference V of a cell is less than EMF, but V is equal to E. Terminal potential difference is equal to EMF. So, in following two conditions, if R is internal resistance is 0, in such a condition we get terminal potential is equal to EMF. If internal resistance value is 0, if this is value is 0, then see here, if the value of R is equal to 0, small r, if the value of R is equal to 0, then if this is equal to 0, R and R get cancelled, remaining V is equal to E. In such a condition, terminal potential difference is equal to EMF. And one more, in open circuit, so in the open circuit, if the R value is infinity, see, if there is an infinite resistance is there in such a condition, so its value is, if R value equal to infinity, then above equation the potential difference equation becomes, see, this is the expression for potential difference, and that is V is equal to ER divided by R plus R we taken here. Then this equation can be written as E divided by 1 plus R divided by capital R. See, if the R value is infinity, if this value is infinity, then if we taken here, then anything by infinity value is 0, then remaining E divided by 1, it becomes E. Hence, in this condition, when R is equal to infinity, we have V is equal to E. Terminal potential difference is equal to EMF. See, this is the one concept. The next concept is the combination of cells in series. See, we already learned the concept of cell. Cell is nothing but, our electrolytic cell is nothing but, it is a simple device used to maintain the steady current. See, if the cells are connected in series, let us consider as two cells. We can consider two or more cells, but now, so when I am explaining with the help of two cells, let us consider two cells connected in series with a like this. The negative terminal of one cell is connected to a positive terminal of the next cell, like that, which is represented in the figure. See, so this is one cell, this is another cell. The negative terminal of the one cell is connected to the positive terminal of the next cell, again like this. So this is the diagrammatic representation here, in which E1 be the EMF of the first cell, E2 be the EMF of the second cell, and R1 and R2 be the internal resistance of the first and second cell respectively. The cells sending a current I. See here, I be the current sending through the cell. So in the direction which is as shown in the figure, like this. So this is the direction of flow of current, and this is the equivalent cell. If these two cells are replaced by a one cell, and this is, we can call it as equivalent cell, of its EMF is E equivalent and its internal resistance is R equivalent, and the current through the cell is equal to I. See, VA, VB and VC are the potential difference or potential point at A, B, C. So, VA is the potential at A and VB is the potential at B and VC is the potential at C respectively. The potential difference between a positive and negative terminals of a first cell is, see, this is the first cell, the potential difference between these two is equal to, which is taken as VAB. VAB is equal to VA minus VB. This is the potential difference across first cell. This can be written as, we know that expression for potential difference is equal to, here V is equal to E minus IR in the case of cell. Then that is same as it is here. The potential difference across the cell is equal to Va minus Vb. That is also equal to, general formula is E minus IR, but we have cell 1 of EMF is E1 minus I is a current which is passes through all cell. Then R1 be the internal resistance of a first cell. Then the potential difference between positive and negative terminals of a second cell. See, the positive and negative terminal of the second cell and its potential difference is equal to VBC. VBC is equal to VB minus VC, that is equal to potential difference between these two terminals. That is also equal to E2 minus IR2. In the potential difference between A and C of the series combination of a two cell is, the potential difference between A and C of the combination of two cells, and the potential difference between these two is equal to, see, that can be written as, the potential difference between AC is equal to VAC. Then that can be written as VA minus VC. Then VA minus VC can be written as VA minus VB plus of VB minus VC, that is equal to VA minus VC. VA minus VB equation is, we have E1 minus IR1, that is we wrote here, plus as it is VB minus VC value is equal to E2 minus IR2. Then here E1 plus E2 first we wrote here. So VAC is equal to E1 plus E2 positive value first we taken, and minus IR1 minus IR2. Here in these two, minus I is a common term, keep it outside. Minus I is a common term, first we wrote that. Later remaining is R1 plus R2. So that is here. Hence VAC is equal to E1 plus E2 minus I into R1 plus R2. Actually this is a R2. So that is a print mistake. So make it correction. E1 plus E2 minus I R1 plus R2. So this is equation number somewhat 3.27. The series combination of two cells can be which is replaced by a single cell. If the combination of these two is replaced by a single cell between A and C, between A and C, the EMF is equal to E equivalent and its internal resistance is equal to R equivalent, as shown in the figure 3.11b. Hence, the potential difference across AC is equal to E equivalent minus I into R equivalent. We have the formula V is equal to E minus IR. Hence, general formula is E minus IR, but here we have E is equal to E equivalent. Hence, this is E equivalent minus I into R equivalent. This is equation number 3.28. On comparing equation number 3.27 and 3.28, we get E equivalent is equal to, see here both equations, here this and this are similar. Here E equivalent is equal to E1 plus E2, that is E equivalent is equal to E1 plus E2. This is 3.29 equation. Then I and I same as it is. Then R equivalent value is equal to R1 plus R2, that is equation number 3.30. This relation can extend it up to n cells. So this can be, we can take n, if we consider n number of cells which are connected in series, then also we have E equivalent is equal to E1 plus E2 plus E3 plus so on En. That is we wrote here. E equivalent is equal to E1 plus E2 plus so on En. Then R equivalent is equal to R1 plus R2 plus R3 plus so on Rn. If we connect the negative, so some replacement. If we connect the negative end of the one cell is connected to another negative end of the next cell, If we connect like this, then equation becomes VBC is equal to minus E2 minus I2 R2. Then the equivalent EMF of a cell in such a condition, E equivalent is equal to E1 minus E2. Then equivalent internal resistance is equal to R1 plus R2. See, this is the concept of when the cells are connected in series, then the value of EMF and internal resistance can be calculated like this. So next thing is, so here in which if we the question asked for only for two cells are connected in series, then these two equations are enough. Then they asked for n cells, then the equation extend to this equation. The next concept is combination of cells connected in parallel. See, let us consider two cells which are connected in parallel between 2 points A and C. See here, this is A and C. Between these 2 points, there are two cells are connected here. If the positive terminal of a cell is connected to one point and the negative terminal of each cell is connected to another point. See, whatever number of the cells you can consider, the all positive terminals are connected to one point and all negative terminals are connected to one point. See, this is positive terminal of the first cell and positive terminal of the second cell are connected to one point. Then negative terminal of the one cell, the negative terminal of the another cell is connected to one more point. And if the connection is like this, which is called as parallel connection. See, parallel connections means all the cells connected to only two common terminals. That is called, that type of connection we can call it as parallel connection. Hence, if the positive terminal of each cell is connected to one point and the negative terminals of the each cell is connected to another cell, another point of a cell, then so this is called as a parallel connection. Let E1 be E1 and E2 be the EMF of a two cell connected in parallel. Then R1 and R2, see here, R1 and R2 are the internal resistance of the two cells respectively. Then I1 and I2 be the current leaving the positive electrode of the cell. See, I1 and I2 are the current leaving the positive electrodes of a cell as shown in the figure A. At B1, see, this is the B1. At B1 a current, see, this is the point B1 and this is the point B2. At B1 the current I1 and I2 flows in, whereas the current I flows out. See, the I1 and I2 merges at B1 and that flows as a I. Therefore, I is equal to I1 plus I2. This I is equal to I1 plus I2. Let V1 and V2 be the potential at B1 and B2 respectively. V1 be the potential at B1 and V2 be the potential at B2. Then potential difference across the cell, that is of the first cell, is equal to V is equal to V1 minus V2. That can be written as E1 minus I1 R1. Since the second cell is also connected to B1 and B2 points, that is exactly similar to the first cell. See, as like this, first cell is connected to B1 and B2, like that the second cell is also connected to B1 and B2, similar as that of the first cell. Then the potential difference across the second cell is also V is equal to V1 minus V2, that is also equal to E2 minus I2 R2, because this is the second cell of its EMF is E2 and its current through the second cell is I2 and the internal resistance is equal to R2. Hence, the potential difference across the second cell is equal to E2 minus I2 R2. Hence, we get I1 is equal to, from this equation, I1 is equal to, so this I1 is actually here, I negative term, this minus I1 R1 is sent to LHS side, we send it to RHS side. Then this equation becomes I1 is equal to E1 minus V divided by R1. And so this equation, so second cell equation, that is I2 is equal to E2 minus V divided by R2. Then from this I is equal to I1 plus I2, we can written as I is equal to I1 plus I2 is equal to, in place of I1, so I substitute this value, E1 minus V divided by R1 plus as it is. Then I2 is equal to this, E2 minus V divided by R2. Then see here, there are some terms like E by R1, E2 by R2, E1 by R1 plus E2 by R2. First we need to write some first initially. So initially we need to take E1 by R1 plus E2 by R2, we wrote here. Then minus V and minus V is here. Then keep it outside, minus V, keep it outside, remaining, see here, this R1 is related to this E1 and V, R2 is related to E2 and V. First E1 by R1, E2 by R2 we wrote here, minus V common term, keep it outside, remaining 1 by R1 plus 1 by R2 is here, we wrote, that is equal to, now so on cross multiplication it becomes E1 R2, so on taking LCM it becomes R1 R2, in denominator it is R1 and R2, and on cross multiplication it becomes E1 R2 plus E2 R1 divided by R1 R2, that is we take here. Then minus V as it is, again take LCM, it becomes R2 plus R1 divided by R1 R2, that is wrote here. Then so this minus term, negative term, send it to LHS side, and this I, positive I, send it to RHS side. Now this equation becomes, so minus V into R1 plus R2 divided by R1 into R LHS side, then it becomes plus V into R1 plus R2 divided by R1 into R2, that is equal to this value, E1 R2 plus E2 R2 divided by R1 R2, keep as it is, minus the positive I, if send it to RHS side, then it becomes negative I. Then we need a potential difference V only. Then this equation send it to again RHS side. Then it becomes, so if we send it to the RHS side, then this becomes cross multiplication here, R1 R2 is top, and R1 plus R2, that is to the denominator. Then I as it is, so after this cross multiplication you will have R1 R2 divided by R1 plus R2, and again it is multiplied to this equation also. So E1 R2 plus E2 R1 divided by R1 R2, then again it's with its cross multiplication, so then it becomes R1 R2 divided by R1 plus R2. Then see here, so don't confuse, here there is a small confusion. One thing, first after cross multiplication, see the equation is like this. Now this R1 plus R2 divided by R1 R2, if it is multiplied to these two equations, it becomes E1 R2 plus E2 R1 divided by R1 R2 into this term is here, R1 R2 divided by R1 plus R2, minus I as it is, and this term is here, R1 R2 divided by R1 plus R2, and R1, R2, R1, R2 get cancelled. Remaining term is R1, E1, R2 plus E2, R1 divided by this R1, R2, R1 plus R2 is here. Then minus I into R1, R2 divided by R1 plus R2. And this is the equation here. Then this is equation number 3.31. If the parallel combination of cells is replaced by a single cell between B1 and B2, then equivalent EMF is equal to E equivalent and equivalent internal resistance is equal to R equivalent. See here. So if these two cells which are replaced by a single cell with the EMF is equivalent EMF and internal resistance is equivalent internal resistance, then so that potential difference across this is equal to V is equal to E equivalent minus I into R equivalent. That is equation number 3.32. On comparing equation number 3.31 and 3.32, see 3.31 is like this. This and equation number 3.32 is like this. See, this is looks like V is equal to E minus IR. Hence, on comparing these two, E equivalent is equal to this value E1 R2 plus E2 R1 divided by R1 plus R2. Then this is here equation number 3.33. And R equivalent is equal to, see, I as it is in place of R equivalent, see, I as it is in place of R equivalent, its value is R1 plus R2 divided by R1 R2 divided by R1 plus R2. R equivalent is equal to R1 R2 divided by R1 plus R2, that is equation number 3.34. Then 1 by R equivalent is equal to what now? So on if we take reciprocal of this value, 1 by R equivalent is equal to R1 plus R2 divided by R1 R2. And if we separate this, then we can write it as R1 divided by R1 R2 plus R2 divided by R1 R2. R1 value cancel, then remaining is 1 by R2. And here R2 value is cancelled, remaining is 1 by R1. Hence 1 by R equivalent is equal to 1 by R1 plus 1 by R2. That is equation number 3.35. Now dividing equation number 3.33 by equation number 3.34, and you will get E equivalent divided by R equivalent, and that equation becomes E1 R2 plus E2 R1, here E1 R2 plus E2 R1 divided by R1 plus R2 divided by this value R1 R2 divided by R1 plus R2. R1 plus R2, R1 plus R2 get cancelled, remaining term is E1 R2 plus E2 R1 divided by R1 R2. See, this is the equation here, R1 plus R2, R1 plus R2 get cancelled, remaining this value divided by this value we wrote here. And this can be written as E1 by R1 plus E2 by R2. This is the expression for equivalent EMF. If the negative terminal of the second cell is one case like this, if the negative terminal of the one is connected to, if the negative terminal of the second cell is connected to the point where the positive terminal of the first cell is connected, then equation E2 is taken as, in the equation E2 is taken as negative sign. Hence in such a condition, so the formula is like this: if there are n cells are connected, if this is another case, if there are n cells are connected, then it's EMF E1, E2, E3, so on, En. Then the internal resistance of those cell is equal to R1 plus R1, R2, R3, so on, Rn respectively. Those cells are connected in parallel, then the combination is equivalent to a single cell of its EMF is E equivalent, and the equivalent cell internal resistance is R equivalent. Such a condition, the formula is E equivalent by R equivalent is equal to E1 by R1 plus E2 by R2 plus so on, En divided by Rn. Then 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus so on, 1 divided by Rn. If the two cells are parallel, of the same EMF E and the same internal resistance R, in such a condition, the E equivalent is equal to EMF. Then R equivalent is equal to R divided by 2. Thank you.